For this one, we've got another piston cylinder assembly. I promise eventually we'll be done with these piston cylinder assemblies. This one contains water. Initially, it's going to be a liquid at 50 degrees Fahrenheit. It undergoes a process of constant pressure at a pressure of 20 psi. And then we're going to go to a final state where water vapor is a vapor at 300 degrees Fahrenheit. We're going to ignore kinetic and potential terms. We want to find the work and heat transfer. Notice these units, BTU per pound, for each of the three parts of the process. Now, it says, part A, we want to know from the initial liquid state to the saturated liquid state, and then we're doing from saturated liquid to saturated vapor, next from saturated vapor to the final vapor state. All of these at 20 psi. We're also going to draw the TV diagram for the process. Let's do that TV diagram first, and then we'll work on it as we go through the problem. Alright, so here's T, here's V. Draw your vapor dome. And for this one, we've got a constant pressure process, so I'm just going to go ahead and draw this pressure line on here. So that's 20 psi, just like that. Now, if you go into your saturated liquid table, you can find this saturation temperature. If you do that, you're going to get 227.96 degrees Fahrenheit. So that's the temperature right here, if you are at 20 psi. So essentially, if you're at 20 psi, this is going to be your boiling temperature. Okay. Now, so let's get started on solving the problem, and then we'll update this as we go through. On part A, we want to go from the initial liquid state to the saturated liquid state. So initially we're down here somewhere at 50 degrees Fahrenheit. We want to go from here up to right here. Remember, that's that F point. So let's look at this first. Alright. And the units, it wants BTU per pound, so we want work over mass. So what you're going to get here, if you went through and did the integrals and everything, you would get 20 for your pressure, and then you're just going to multiply it by the volume change. So here we'll have specific volume at F minus the specific volume at 1. Now, if you were to go through and look in the tables, this is compressed liquid down here at 50 degrees, but you might not be able to find that in the table. So remember, you can use an approximation for that. And for our approximation, you'll use the saturated liquid table. So we're going to say V1 is approximately equal to VF at temperature T1. And that's going to give us 0.01602, and that's cubic feet per pound. All right. And that gives us V1. And notice T1 here was 50 degrees. Now for VF, that one is going to be this point right here. So now we've gone up to that saturation temperature. So you can just use your pressure table for the saturated liquid and pull out that VF number. And this will be for a pressure of 20. And that's going to give you 0.01683 cubic feet per pound. Now we can just plug these values into this equation. And then, of course, you know, we always have to do a unit conversion here. So there's our pressure, 20 psi. Put the specific volume values in here. So the first one will be 0.01683. And subtract 0.01602. Those are both cubic feet per pound. And now we want BTU per pound. We don't have BTU anywhere in here, so we need to work towards getting that. We also have this inches squared over here. We need to get rid of that. Notice this is cubic feet. So typically you don't want to have inches in here, you want to convert over, so let's get rid of that. So we'll use 144 inches squared per foot squared. And then to get to BTU, we're going to have 1 BTU per 778 foot-pound force. And that's your last conversion there. All right, so now after you do all of that, everything ends up going away except for BTU and then pounds, because this foot combined with this cancels this. Inches squared goes away, pound force goes away. All right, so you got BTU per pound. So your work per mass is going to be 0.003 BTU per pound. So there's that for part A. All right, now we got to find Q over M because we want the heat transfer term. For this one, you're going to use that energy balance equation again. So if you look at that, you're going to have Q over M. That's going to equal delta specific internal energy plus work per mass. This is just reorganized here. And using that, we could say we have the specific internal energy at point F, because that's our final point. We're going to subtract U at point 1, and then we're going to add to that the work per mass, which we just found right here. And that's BTU per pound. All right, now this one again, U1, this is that compressed liquid. We're going to use that approximation where U1 is approximately equal to UF at T1. So just like we did up here, use the temperature 50 degrees Fahrenheit, find that saturated liquid value for specific internal energy in that water table. Now if you do that, the values you're going to get, you should get 196.19 for UF, minus 18.06 for U1, and then add to that the 0.003 BTU per pound. All right, and these units all work out. So that's going to give you a Q over M of 178.13 BTU per pound. All right, so now you got that. That's for part A. So that takes us from 1 to F. Now we need to go from F over to G. All right, so this is part B, this was part A. And again, we've got this same equation for the energy balance. Delta U equals Q over M minus W over M. Okay, so for this one, let's find work first. So our work per mass is going to be the pressure times Vg minus Vf. And again, this is just after you do the integration and all that. That's what you would get. So now with this, we can plug in our numbers. So pressure is 20. It's PSI, and then the values you get here in the table, again, you would just look these up in your saturated water table, and you're going to get 20.09 for Vg, and then for Vf you get the 0.01683, and those are cubic feet per pound. And then again, you got to get rid of the inches and then convert over to BTU. So you're going to use these same two conversions we did here. I'm out of room as usual. I need to write smaller. All right, so there's the conversion to get rid of inches, and then the last one is the conversion to BTU. Okay, so now you got that. And that'll give you a W over M of 74.31 BTU per pound. And then finally, for this part B, we need Q over M. using this equation, you're just going to find U. So we need UG minus UF. And then you're going to have your work term here. So we're going to have plus 74.31. And it's plus because I've reorganized this equation, right? So I move this one over so that switches to plus. This UG value from your table is going to be 1082.0, and then the F term is going to be 196.19. So solve for that. You get Q over M of 960.12 BTU per pound. So we're gaining energy from heat here. And last one. C is we're going from saturated vapor to the final vapor state. So let's just say we're going up here, that's state 2. That's going to be at a temperature of 300. So we're going to have superheated vapor at that point. Essentially, you're going to follow the same exact process. Okay. So let's do W over M first. Just like we've done in the past, we've got our pressure times our values. So you're going to look up the U term at 300 in the superheated vapor table. And then for the next one, you would have this G value for V, which we already found here. So just take the value used here, so the 20.09, and then find that value. So that's going to give you 20 for the pressure. And then for your change in V's here, you'd have 22.36 minus 20.09. And I'm running out of room here, so I'm going to leave off the units. And then do your conversions just like we did here and here. So you're going to have 144 over 778. And then that's going to give you 8.4 BTU per pound. So there's that. And then finally Q over M. Same steps we did here. We're just using this basic equation. You just need to find your internal energy values at this at state 2, and you already have the one at this G point here where we had saturated vapor. So just go to the superheated table and look up that temperature and find your specific internal energy value. And then with that, you'd have 1108.7 minus 1082.0 plus 8.4. So that's going to give you a Q over M of 35.1 BTU per pound. Like that. Okay. So that one had quite a few steps to it, but that's how you go about working through there. All right, so hopefully y'all were able to look up the values in the table correctly, and I will see y'all later.